Hello, you're welcome to this video. Now right here we'll be integrating this function of x. We have sine of x, cosine of x, e to the negative sine of x. Wow, this seems so complex. Now let's get on with it. Okay, great. Now first of all, I'm going to tell you what I'm going to make use of. I'm going to start by making use of the substitution. So looking at this clearly, if I have e to the negative u, it will be very great, alright? Great. So let me just do something. Let's say that our u is equal to sine of x. This one, let me use a better ink. Our u should be sine of x. Okay, so in that case, we will have our du to be equal to what? We'll have the derivative of sine of x is just cosine of x. I know du dx is giving us cosine of x, so that means du will be giving us cosine of x dx. Okay, great. Now we have this. The next thing I'm going to look at is the fact that we have cosine of x here and we have the x. So in this integral, we can do some rearrangement. We have integral of sine of x. Okay, we have e to the negative sine of x and cosine of x. All right, the x right here. Sorry for that. Okay, now this is actually the x. So this bracket, you know what it means, so let's just take it off. Okay, great. Now we can do major substitution here, where our u is sine x and our du is cosine x dx. Okay, so we can just go ahead and plug in u for sine x, and that gives us u right here, e to the negative u. Now cosine of x dx is du. Okay, so we've properly substituted u for the functions of x. Great. So next we consider, alright, since I'm just having the u, I can just change that to blue ink to rhyme with our integral sign, alright? Great. So we go ahead and integrate this u times e to the negative u with respect to u. Great. So by here we can make use of our integration by parts, where I will say, okay, let's make our w. In this case, let's use w. Okay. Integration by parts goes that the integral of w dv should be equal to wv minus integral of v dw. Okay, so we're going to use that right here, and if you want to compare this to this, which is actually what we're defining, w is in place of u. So we have that our w should be equal to u, such that if you differentiate w with respect to u, we're going to have du. We have that our w is the same thing as du. Okay, now comparing this to this, we have that our dv is just equal to e to the negative u du. Okay, so since this is gotten from the derivative of v with respect to u, and it's giving us e to the negative u, let's integrate both sides. So the integral of dv is just v equal to the integral of this right here, e to the negative u du. Okay, so if we integrate that, we're going to differentiate this exponent here. The derivative of negative u is just, the derivative of negative u with respect to u is just negative 1. So we're going to have e to the negative u divided by negative 1, which is just negative e to the negative u. Okay, great. So this is our v. Now, integration by parts gives us this. We're going to make use of this. So we just go ahead and substitute. Let me press this. Let me compress this. So we'll have that my v is the integral of this right here, which is just negative e to the negative u. Great. So plugging this here, all of this, we have w to be u, v to be negative e to the negative u. Just follow up, right? It's very clear. Integral of v is negative e to the negative u, and the w is just the u. Okay, now we can go ahead and integrate this. Okay, so remember, like we did right here to get our v, we're integrating this, we're having e to the negative u divided by negative 1. That's just negative e to the negative u. So the integral of this respect to is just negative e to the negative u. And remember, we have a negative sign right here, and at the same time we still have a negative sign outside the integral, and this is negative already. Okay, so we have 3 negative signs that just evaluates to negative. Okay, let's go up. Great. Now we have here negative u e to the negative u. These 3 negative signs is just negative e to the negative u. What was our u? Our u, we said it to be sine of x. So at this point we can just call it to be negative sine of x. Okay, e to the negative sine of x minus e to the negative sine of x. I know e to the negative sine of x is common, so if you take that out, already we've gotten an integral already. And remember to add your arbitrary constant for any constant. Okay, so we have the plus some constant c. Great, so we can take this out, e to the negative sine of x, which is common, and we have the remnant inside the bracket, which is okay, we can either take negative out. We have sine of x plus 1 plus some constant c. So this is the integral of sine x cosine x e to the negative x. You know, start from the u substitution. From there you get on with the substitution by parts, or the integration by parts rather, and that gives us this. So to confirm this, just differentiate this right here, and I believe you're gonna get this back. Alright, thanks for watching. Please subscribe to Sinxcosxe channel. Thank you.